All right, thank you very much. So Pravin and I work together quite a bit. Pravin has the process side of the PLM team there at Textron Aviation. So I have the IT side and process side, so definitely work together. We don't have IT projects, as Kimberly was talking about. The worst thing you can do is probably have an IT project. It's, their business projects and business initiatives. And so I'd like to go through real quick a little bit of context on Textron Aviation and our parent company, Textron. So Textron as a whole is composed of Textron Aviation, Bell Helicopter, our industrial segment, Textron Systems, and then the finance team. Textron Aviation is, so our revenue is around $5 billion. Service is a big piece of that, about a 70-30 split in terms of aircraft sales versus aircraft service. Service is a big thing for us with our customers. From a product perspective, we about 3 years ago, we went through probably the largest general aviation merger between Beechcraft and Cessna, $2 billion companies that were, I think back in the day, it was Walter Beech and Clyde Cessna 80 years ago were actually partners. Then they split for 80 years, and now we're back together again. So kind of an interesting situation there. Our line of products, biggest in general aviation right now, over 20 plus different products, everything from the line of jets through the King Airs, through the piston products that many people learn how to fly on. 23 different products, over 150 million flight hours. That middle number, 10 products certified in the last 5 years. I think you extend that to 10 years, it's probably, I think it's 23 products is what I've heard. I think that is probably one of our strong suits is how, time to market, how quickly we can deliver new products in the space. Our service network. So, as I said, customer is very important to us. We have a lot of places over the globe that we support our customers through. A big focus, especially on the technology side, in terms of how we give our customers apps and things that they can quickly look on. If they're having their aircraft maintenance or maintained in one of our service centers, while they're there, they can actually look at an app and see the progress that's going on. Many of us probably wish we could take our car to a dealership and get that. We're providing that for our customers. Okay, our partnership with Dassault. So we go way back. I think probably the very beginning, clear back in the V1, V2, V3 days. We started on the mainframe. We transitioned to Unix and has made that conversion over to Windows. You can see the various products. Supporting everything, the whole product life cycle from design through manufacturing and service. If you look at our strategy there on the bottom, the 5 bullets, we've been very successful with implementing new technology on new programs. Our leadership has been very supportive of that in spite of our fears sometimes. I know many times it kind of feels like we're trying to change the wheels on a car while it's still moving, or the train tracks, or whatever term you want to use. But on all those products, we're right in the middle of a new program with an accelerated schedule. And oh, by the way, we decided to do something different, whether it was implementing V5 on the Mustang, or on the Latitude, we did V6 and an V6. And then recently on the Longitude, Scorpion, and Denali, we're both V6. So a little bit of a roadmap. I've seen several roadmaps that look similar. This didn't plan it that way, but it's kind of very similar to some of the others we've seen. You can see the timeline of the various aircraft programs as we advanced in the technology. And as I said, most recently, the last 4, starting with the Latitude, was all on CATIA 6 and Innovia 6. Now, our core engineering bill of material is still on the mainframe. So we will author the definition and the bill structure inside of CATIA, sync it up to our master bill of material system, and we're in the process of trying to migrate that into Innovia. So along come the Denali program, and we're looking at ways how can we speed that program up, what can we do on that program that will help them go faster. And the graphic there on the left, the kind of blue circles inside the square box is kind of that core definition that was on the mainframe. All of the blue bubbles that are extending out from that are individual, I'd say, isolated systems that evolved over the last 20 years. So the whole thing with experimental build and conformity or certification tracking or the experimental planning system. So all those tools evolved independently, and what our experimental team was having to do was pull data from different sources and mash that together to try to understand exactly what is the configuration of the aircraft when we were actually doing flight test or doing static test articles. So we took that on in the Denali program, and Pravin's going to come up here and share a little bit more about from the business perspective of what was the change and what was our strategy on how we went about doing that. So Pravin, I'll let you have that.
Thanks, Jeff. Some of the main drivers we have from an engineering standpoint, what we continue to look at and partner with the IT and work on the new technology to bring to the new programs. So if you look at from the design cycle of the aircraft, we are a very regulated industry. If you look at it, we have conceptual design, then we put together the preliminary design, then the testing comes into the picture and the certification. So from these 4 phases, we continue to get challenged how we can get aircraft certified faster. You saw Jeff said we have certified 10 products in the last 5 years. Still, our CEO continues to challenge that he would like to see a product certified within 24 to 30 months. In order to get that, we have made substantial improvement in terms of automation, more from the release and authoring side. So if you look at it, testing and the certification side, that's where we have an opportunity where we can modernize our current processes and make efficiency gains where we can certify product faster. So that was one of the main business driver we had. The second thing is a design collaboration. We always try to have a cross-functional team up front working together, whether they are designers or people running the simulations, tool engineers, planners. The main piece we need to also have, we need to have a voice of experimental. And how we are different as a Cessna or a Textron Aviation is when you design the aircraft, the units which go into the test program, we build those 3 or 4 units in the experimental, and the unit number 5 onwards for that model, maybe in a manufacturing, that's where we go in operational. So the experimental is a key portion of our certification program. So that's where we have a need to have more collaboration with the experimental. Third thing is efficiency. So if you look at it, we have the way that Jeff said, right? We have the basic engineering bill of material. When we design, when you're going to transfer that information to the experimental, it needs to be managed in the one cohesive system where over the years we had so many bolt-on systems you've seen. So there is a recreation of the data or inefficiencies which are built into the current processes. The next one is the communication. That is how the communication happens between the system. That is within the engineering bill of material when it transfers to build those units in the test article, how that communication happens, as well as if you really look at it, you have designers, you have shop people, that's a quality, and the shop floor folks who put together test articles. So we have a need to have a better communication process there. The last one, aging legacy system. So like the Jeff said, the system we are using called as a PIAS, which was primarily brought in as an inventory management system, and we continue to put bolt-ons onto it so that we are using that today for our new product development and certification. So those were the main drivers we had which motivated us to modernize our certification and the conformity process. Some of the risks we have in this project. The first is risk of not changing. We have, over the last 30 years, we have certified products in the current system. Why do we need to change it? The main piece here is this legacy system are not sustainable, they are not supported, so we keep on spending more money. Plus, if we want to make any improvements, it becomes super challenging into that system. The next main piece is the change is the risk. What that means is, if we are going to go into the new system, how are we going to align the schedule of development of that system with our product development so that we don't come into the critical path for a product certification, and we enable the new program to use this system to certify the product. The maturity comes in terms of two pieces. The way I see it, the maturity of the product that we are going to use, that's the Delmia Velocity. Is it ready for our use? How much customization we need to do? Second thing is maturity of our team from a developer standpoint as well as from the consumer standpoint. Are we ready to consume it? And the another piece is the communication throughout the project, how we are going to handle the communication with the various stakeholders we have. And I'll go in more detail down the road. And how can we reduce the learning curve on this program through the various training we put together and conduct. So these are some of the drivers, risk we look at. I think I walk you through the most of the decision process that we went through. Main drivers for us is to get out of the legacy system and how we can make our new product development process faster. The second piece is the maturity. The third piece is the important one, the implement and schedule. I talked about that slightly. We'll go through in more detail in the following slide. And the bottom line is we need to have a risk mitigation plan. If we don't succeed in implementing or moving to the new system, what is our backup plan? I think here our backup plan was to maybe go back to the old system. So if you look at it here, this journey for this project, it started almost a couple of years back. If we look at it 2015, it's a part of our PLM roadmap. We call it this as a phase 2, where we are focusing on conformity and certification. Phase 1, the way I said, it was more focusing on the authoring and the release process. So in a conformity and certification process, we started gathering requirements that what needs to move into the new system. When we are looking at a new system, we want to make sure we have efficient processes when we are going into it. We don't have to just fall back and replicate what's in the legacy system. So we captured those requirements, laid out the schedule, how long it is going to take us to develop the system, and then do the testing. The couple of main things here is you're going to see those stars which are here. Those are the drop dates we have if we want to use this system on Denali. That's the new product which is coming out for us in early part of 2020. So the conformity portion, what that means is when you want to put together all the test articles, that's a static test article as well as all the flying articles we'll have in a flight test, we need to have the conformity portion ready by, it was a few months back, that is the summer of 2017. And then some of the improvements we're doing towards the certification, it's due for us end of this year, where there will be improvements towards all the documentation we will put together to certify our aircraft. The following is the schedule. If you see, that's from the program Go that happened more like end of 2016, early part of 2017. If you look at it here, we have close to 30 to 35 individuals dedicated to this program from various disciplines, starting from design, quality, all the developers, as well as working closely with our Dassault team. And the impact of this project, specifically on the Denali, in terms of users, is close to 100 users will be using the Delmia velocity portion of it, and close to 600 as a whole from the Innovia side. The couple of main things we did here, we took off the shelf velocity product as well as Innovia, some of the customization we have done, and that is one of the main focus we had because we have not worked in velocity from a developer standpoint. So bringing them up to the speed, taking help from Dassault to lay out the architecture and rolling that piece out to the shop floor where they will be using the system first time. And then we have made integration, it continues to, so if you look at it, Innovia talks to velocity as well as both systems talks to the SAP, and the another system is the IFDS, that's the homegrown system we use. It's for the flight data recording. So these are a couple of examples I'll walk you through. If you look at the legacy system, if you want to complete the conformity at the Denali, if you look at that scale of program, we're looking at finishing 600 conformities that we will have to fill out those requests and complete them in order to build all the test articles and the flight test article on the shop floor. You can look at this screen. The message here is the data is being repurposed. You have multiple screens to look at the data. Sometimes you're recreating that data into the spreadsheets, keeping those at the desk. There may be some small homegrown or the Access databases people may be maintaining to track the data. A lot of touch points which are here are a web-based application. If you want to pull the record, report and give that report to the management, it's pretty challenging, very time consuming. So the bottom line message here is it's a very labor intensive process, multiple source of data, and we're using a multiple system. This is the outcome of the project. So this is, I call it as a unit BOM. You can see it on the left-hand side of the screen. The way Jeff said, we have engineering bill of material, which automatically now getting transferred to the velocity. That's where the unit bill of material is being used to build those test articles into the experimental shop. In order to pull the data, how we are going to conform, they see those statuses here with some of those red dots which are there. You want to pull the drawing, you have the information at the same place, and so various systems from where the data comes, you can see on the one dashboard. The beauty of it, it's a real-time data. When there is a change in the engineering, it gets transferred to the velocity that is used on the shop floor. It's a very big thing for us because if you look at it, if that data is not transferred to the shop floor, what you're doing is you may be working with the Rave A on the shop floor. Engineering may be already at Rave B or Rave C. What that means is whatever they build, you have to either do a rework or scrap it. And that's from overall schedule standpoint, it's a setback because you are losing your time in order to certify your product. At the same time, you're wasting your money too. So that's the biggest advantage we have gotten with the new system is real-time data. There is no repurposing of the data. If it's happening behind the scene. The user don't see it. User only sees the one source data. And it's easy to access. If you look at it from a designer standpoint, or if you go on a shop floor, it's accessible on the tablet. So you have this dashboard available to see and fill out those forms. So some of the benefits we got out of it, I already hit some of those here, is from a data visibility standpoint. It's a huge gain for us, which kind of walks through on the right side of the screen. You have engineering bill of material get transferred to the U-BOM. You can really see those on the tablets which are used on the shop floor. So you're doing a right thing at the first time, which reduces a lot of rework for us. More data available, latest data available, you're making a lot better decisions, better quality decisions. And the another piece here is we have moved the experimental process as a production process into the overall processes we use to build the aircraft.
And from the IT side, we was able to go from 8 different disconnected systems down to 2. We have a strategic platform going forward that is maintainable versus what we have today. And as we talked about, single source of data and then real-time updates. So as the shop folks are putting parts on the aircraft or taking parts off, it's real time, they're clocking the parts, and we know exactly the configuration of the test article or the flying article. So key takeaways summary. So we made a conscious decision to move forward with Innovi and Velocity. We had very little exposure to that, and so far we've been very successful with it. Getting a lot of really good feedback from the shop, experimental shop, in terms of how efficient it is. We did limit our risk by continuing to run the old system in parallel for a period of time until we said, okay, we're done. Let's cut it over and switch that on. And was able to stay in front of the train on the program needs. We talked about the reduction in different systems on a sustainable platform. We currently have 14 test articles in it. Every week there's more added to that. And as we said, we're on track for end of year with full flight mode. Right now, the functionality we have is for the individual test articles of systems, and then the actual full up aircraft is due here within the next few weeks. So, all right, next steps. We're continuing to look how we can modernize our environment for engineering. We're looking at new capabilities. We're right in the middle of a 2017-2018 X review in terms of where does that fall within the whole cycle of all the products that we're developing. Looking a lot at model-based definition as to how can we leverage that capability. Additive manufacturing is another area that we're looking at for temporary tooling, and doing a lot of things recently with virtual reality, with instead of doing a conference room design reviews, doing it with a headset straight out of CATIA and getting some really good feedback on that, and then also evaluating one part. So, and I think that is all we had for today. I think questions are going to be later at the panel, so appreciate the opportunity.